In the preceding, we saw that the non-homogeneous system y prime plus p of t y plus g of t with initial condition y of t naught equals y naught yields a solution of the homogeneous equation, which can be written in terms of a fundamental matrix. That fundamental matrix satisfies the homogeneous equation. We postulate a function u of t, a vector function u of t, such that this solution matrix psi of t times the u of t vector solves the original non-homogeneous equation. And by some actually pretty simple steps, we conclude that u prime is going to be psi inverse times the g function. Remember, psi is a solution to the homogeneous equation. It's a fundamental set, a fundamental matrix. As such, it is invertible, so that u prime is the inverse of our fundamental matrix times the non-homogeneous part, the g function. So, writing that down again, u prime equals psi inverse g. And we want to find u, so we're just going to have to integrate. Now, it's going to help in the integration if we have a u naught, which is just psi inverse times our y naught. Remember, we had y of t naught equals y naught. So if we let psi inverse of y naught equal u naught, then our integration can be done where we integrate u of t from t naught to t, where we get u of t by integrating u inverse g from t naught to t, and we'll use a dummy variable here. I think the textbook probably uses s, psi inverse of s, g of s, ds. In any case, we integrate this matrix in a fairly obvious way. At least, hopefully, we can do the integrals, and there's no guarantee that we can. And then add our u naught, so that when t equals t naught, u of t has to equal u naught, because of course when t equals t naught, the lower and upper limits of the integral are equal, and the integral gives us 0. So this function will satisfy this initial condition, and then we're going to simply multiply multiply the u of t function on the left by our psi matrix according to our original premise, and we're going to get a particular solution that does agree with the original initial condition. Now, you recall the whole assumption behind this, and that was done fairly recently, so hopefully you still got it in mind. Particular solution matrix is psi of tu, psi of t times u of t, and make that u of t now, is psi of t times the integral from t naught to t of psi inverse of, I'm going to use s as a dummy variable now, just to flesh things out. So this integral, now we have the dummy variable in here, so we can see what we need to integrate with respect to, and we could use any letter in here. We don't want to use t because t is part of the limit on the limit of the integration. And then we do psi of t times u naught. And of course, psi of t times u naught, since u naught is psi inverse of y naught, psi times psi inverse of y naught is just going to give us y naught. So again, this solution is going to satisfy the condition that when t equals t naught, making this integral 0, we do get a solution that is equal to our original initial condition y naught. We'll continue in the next clip with an example, but the process is actually very straightforward if we know how to find our psi matrix, and as long as our g of t function isn't too awful, we should be able to do the integrals and obtain our particular solution. But let's see how that works out again in the next clip.